Not all acid-base definitions perfectly fit the Arrhenius theory. Therefore, it's necessary to redefine acid bases, not as those that donate hydrogen protons or hydroxide, but rather as proton donors and proton acceptors. In any type of acid-base reaction, there is always going to be one that accepts protons, gives away protons, the donor, that is the acid. The acceptor is called the base. So let's try some problems knowing this idea. Please note that this acid-base or alternate acid-base theory is sometimes referred to as the Bronsted-Lowry acid-base theory. Once again, this alternate acid-base theory is referred to as the Bronsted-Lowry definition of acids and bases. It is not the Arrhenius theory. According to one acid-base theory, a molecule acts as an acid when the molecule Remember, acids are proton acceptors, so they donate hydrogen. Thus, answer choice 3 is correct. Given the equation representing a reaction at equilibrium, ammonia plus H2O is in equilibrium with ammonium ion plus hydroxide ion. If an acid is defined as a proton donor, what is the acid in the forward reaction? In order to do this problem, look at the reactants and see how they change. Which one of these reactants is donating hydrogen and which one of them is receiving? Now look at NH3. NH3 goes from being NH3 to NH4. So what happened? Well, one of these hydrogens from water gave it to NH3 in order to become NH4. What are we left with? OH minus. So in this case, the one that's donating the hydrogen to the NH3 is water in this case. So water acts as the acid. Here, ammonia acts as the base because it receives that proton in order to become NH4. Sometimes the regents will ask you to classify acids and bases in the reverse way. So the same rules apply. What does ammonium do to hydroxide in order to go from products to reactants? Well, in this case, ammonium would be the proton donor, which would make this the acid. It gives the hydrogen to OH minus in order to become H2O. Therefore, ammonium ion is the proton donor, making it the acid, and OH minus is the proton acceptor, making it the base. If we're looking at the forward reaction, H from the H2O is donated to the NH3. Because this is the donor, this is the acid. Because this is the acceptor, this is the base. Which statement describes one acid-base theory? Remember, the acid, according to this acid-base theory, is always the proton donor, and the base is always the proton acceptor. This is the only way it's defined. So, when it comes to the acid-base theory, remember that the acid is the proton donor, and the base is the proton acceptor. In order to determine which one is donating, look at the reactants and see how they change from reactants to products. Here, NH3 became NH4. So that means it had to accept a proton, making it the base. H2O became OH minus, which means it had to donate its hydrogen, making it the acid in this case. Thank you for watching.